This video file called homework.mp4 is almost 8 petabytes long. I cannot open it normally, nor can I recycle it. It's simply too large. 8 petabytes is not a joke. It's 8,192 terabytes. Do I own a data center by any chance? No. I only have a 512 gigabyte disk, which isn't filled? What's the catch? Windows, and specifically its beautiful NTFS file system. The homework video is not just a normal file, it is a sparse file. And this is not a standard Windows install either. It takes a surprising amount of space, 377 gigabytes of data, and it might sound heavily inflated to you, which is a completely right call. A regular clean Windows install takes around 20 gigs of storage. Why is that, you might ask? The reason for that is cluster size. That's a classic file system property. A cluster is the unit of allocation on a volume. Notice it's different from files. Files are basically records, and they're located within clusters. Think of clusters as labels for physical surface on your disk. Files are not guaranteed consecutive clusters, which causes fragmentation that you need to defrag on HDDs. It's really simple. Sequential data reads are so much better than random reads, which is physically intuitive on hard drives. The head moves less because the sectors are next to each other. So the cluster size controls how large each physical unit is. Since files use those physical units, each file in the file system is at least the size of a cluster, with an exception to files less than around 700 to 800 bytes, due to the master file table record taking up 1 kilobyte by design. That inflated install size is primarily caused by the so-called slack space, where the file cannot fit inside the record in the master file table, but doesn't occupy the cluster entirely. In my case, the cluster size is 2 megabytes, which is disgusting and unoptimal, and incidentally the maximum cluster size for NTFS. The only reason I had to make clusters so clunky and horrible is because it's the only way to optimize for file size. Windows is optimized for 4 kilobyte clusters, which aligns super well with memory pages, which are also 4 kilobytes long on Windows. Compression also only works with clusters 4 kilobytes and smaller by design. It just totally makes sense. The only problem is that the NTFS driver on Windows locks the amount of clusters per file to 32 bits, or around 4 billion, while NTFS is actually 64-bit capable. That is a drawback caused by a stupid driver forcing the 16 terabyte limit per file on a regular Windows install. The only way to increase the limit is by increasing the NTFS cluster size, which is a complete hack. You won't need to do that with a driver properly implementing NTFS. Microsoft failed here. So on Windows, the largest theoretical file is 8 petabytes minus 2 megabytes long. That is 2 to the power of 32 minus 1 times 2 megabytes. It's all theory, but can be proven in practice. And the sparse files will help us prove the limit. Sparse files are a feature of NTFS and go largely unrecognized by Windows users, though really powerful. They help store sparse data, or data which is purposefully stored with a lot of zeros in between. Those zeros can be squished, kinda like compressed. Those are just nice to have for your virtual disks that aren't fully allocated in storage, though for example VMware does not use that, because the VMDK format implements sparseness on its own. We can use fsutil to create sparse files. It's included in Windows. First set the sparse flag, then set the end of file, then the range. And that's it. Now you also own an empty 8 petabyte file. For all of you, it will be around 16 terabytes if you try it on your machine because of the 4 kilobyte optimized cluster size. In theory, you can reach 16 exabytes, minus a kilobyte. That's the NTFS limitation. On Windows though, it's around 8 petabytes, as shown here, and only if you go for an unoptimized setup, which you can't even install through normal means. So that's how I got my largest file on NTFS. Thank you for watching, and take care.